For our next example, we consider an infinite sheet of charge with uniform surface charge density sigma coulombs per square meter. Here the charge density has planar symmetry, namely, charge is uniformly distributed over a single plane. Consequently, we know that the direction of the field must be perpendicular to the surface. To determine the electric field at any point, we need to choose a Gaussian surface whose surfaces are either parallel or perpendicular to the plane, so that E dot dA will be either 0 or just E times dA. With such a choice, we will be able to take E outside the integral and solve for it. So let's choose a cylinder that cuts to the plane as shown. Here, the field is parallel to the barrel surface and perpendicular to the two end surfaces of the cylinder. Since the field may depend on the distance from the plane, we'll position our cylinder so that the two ends are equidistant from the plane. We'll now apply Gauss's law. For the left-hand side of the equation, E dot dA will be non-zero only on the two ends. At each end, the field points away from the plane of charge in the same direction as dA, which always points away from the inside of the volume. Therefore, the contributions from each end are the same, leaving the total integral of E dot dA over the surfaces equal to twice the product of E and the surface area of a single end. For the right-hand side of Gauss's law, we need to determine the charge enclosed by our cylinder. The intersection of the plane with our cylinder is just a circle of area A. Consequently, the total charge enclosed is just the surface charge density sigma times the area A. Putting this all together, we obtain the final result, that the magnitude of the field produced by an infinite sheet of charge with uniform surface charge density sigma is just equal to sigma over 2 epsilon naught. Perhaps this result seems surprising to you. The field from an infinite sheet of charge does not depend on the distance from the sheet. We can actually understand this result if we think about the field lines produced by an infinite sheet of charge. Since the sheet is infinite, the direction of the field must be perpendicular to the sheet. Therefore, the field lines must also be perpendicular to the sheet. The magnitude of the field is given by the density of these lines. The density of these lines must just stay constant. There is no place for them to expand into. Consequently, the magnitude of the field produced by an infinite sheet of charge must be constant.